Kan nampak?
Nampak.
Okay. Kan ni part 1, part 2 kan? 1/5. Lepas tu ni MOM. Part 2, 1/5 report. Part 2 kan? So, apa kata macam contoh kita bagikan macam ni. MOM ni kita semua buat sama-sama. Sama dengan part 2 ni. Sebabkan MOM ni kan ada banyak kan. So, aku suggest macam contoh ni aku. Satu-satunya aku buat. Lepas tu 2 ni Aimi buat. 1.3 ni Alif buat. Lepas tu 1.4 ni Melina buat. Lepas tu 1.5 ni Aimi buat. Compile ni aku buat. Macam tu. Lepas tu kita repeat balik. 2.1 ni aku buat. Lepas tu ni Aimi. Ni Alif. Ni Melina. Lepas tu yang 2 ni, yang 2.5 dengan compile report ni orang yang tak ambil 2 part dalam part 1 ni. Okey tak? So macam seorang ada 3 part lah macam tu untuk lab ni.
Okey juga. Aku okey je.
Sebab kita kan tak ada buat video lagi kan. Sam ni minggu ni kan. So aku rasa macam okey lah sebab MOM ni pun dah kira macam banyak agak lah kan kerja dia. So korang kat tepi ni boleh lah chop tempat.
Assalamualaikum Doktor. My name is Ilya Aimee Shakira binti Zakaria. Metric number C200007. For 3.1, tabulate the desired output for feedback control experimental data. For applied voltage VA is 10, back EMF constant KB is 1, disturbance amplitude TD is 0.1, CS K over S, C is equal to 0, 5, 10, and 15. Thank you.
Assalamualaikum and good afternoon. My name is Alif Azhan bin Abdul Rahman. My matrix number is CE2001X2. Okay, I am being given a task to do 3.2 where the question is repeat the 2.1 experiment by adding a feedback control, integral control to the system to improve the steady state response. So I'm sorry I'm present on these words because I don't have MATLAB on my laptop because it's not support. So I'm using my friend laptop to do, and I the print screen the result only. So for the experiment, we need to use the previous lab block diagram, and we add the integral control. Where this is the integral control, and so this is the block diagram that I changed. Before this, we use a KF like the triangle one. So the graph for the K is 0 is this, and as a result, it show the output response after we insert WREF 10 and back EMF 1 and TD 0.1. In the system, we use K equal to 0, and from the graph, you can see that the response does not reach the steady state value, which 10. And suppose got the value beside the graph, but I only pre-skin the graph. So we get the steady state error of the response is 9.6, and the overshoot of the response is 7.471%, while its rise time is 130.921 ms. Okay, that's all for this question. Thank you.
Assalamualaikum and good day. My name is Nur Shafura, AE190126. Today I will explaining on part 3 for question 3.3. As you can see, the question states that tabulate and study the effects of CS equal to K equal to 0, 5, 10, and 15. So we will use this block, and for K block, we will add another transfer function block, which is K over S. Actually, this is K over S. K is equal to 0, 5, 10, and 15, and S is equal to 1. So we will add this block to our block diagram. So by using VA equal to 10 and KB equal to 1, we use pulse generator amplitude 0.1. So first we will put K equal to 0 first, and then 1. The result is the graph will look like this. So here is the value of steady state error value, which is 0.094. The rise time is 212.320 millisecond, like that, and the overshoot is 0.496%. 5. We put K equal to 5 and run the simulation. The graph will be look like this. As you can see here, the steady state error is 1.102. The rise time is 245.067 millisecond, and overshoot is 2.967%. K equal to 10. This is the result for when K equal to 10. So the steady state error is 1.467. Rise time is 161.291 millisecond, and overshoot is 9.341%. And lastly, when K equal to 15. So the graph won't change much, but the value only the value of the steady state error, rise time, and overshoot change. So here for K equal to 15, the steady state error is 1.699, rise time is 124.905 millisecond, and overshoot is 14.368%. So I will pass to my group member to explain for 3.4. Thank you.
Okay, for the part 3.4, the question asks to discuss and compare the result obtained using two methods, which is feed-forward and feedback control. As we see the result, experiment by adding a feedback control, the system to improve the steady state response. The diagram 3.2.1 show the graph for the motor have integral action is added to the controller to minimize or eliminate offset is in disturbance. So here the diagram 3.2.2 shows the result as it eliminates as feed-forward control used in conjunction with feedback control. The result we get after adding KFF brings the disturbance rejection performance of the different control, which means feed-forward control takes corrective action before the disturbance entering into the process. This combination will allow compensation for measured and unmeasured disturbance as well as model mismatch. Now, as we see in the diagram 3.3.1, there is no changes because the K is equal to 0. And when we see the diagram 3.3.4, it shows the smoother than the other diagram result because the proportion action provide the quick response to correct for the upset, where the integral provide the gradual correction to bring the control variable back to the set point. So that's all from me. Thank you.